Good morning. Today we are going to be learning about complex numbers. Now, complex numbers are a sort of a growing out of what we just learned about imaginary numbers last week. And essentially, what we're going to be doing is talking about a much larger scale of numbers that encompass everything we could really possibly work with in Algebra 2. And so, what I want to talk to you a little bit about is how those numbers actually work. When we talk about complex numbers, essentially what we're going to be looking at is sort of an umbrella idea of all the possible numbers that we have. Complex numbers covers anything that involves a real number, which is really all of our whole numbers, all of our fractions, all of our decimals, all of our square roots, all of our irrational numbers, those things like pi that go on and on forever and don't repeat. Basically, any number that we've used up until last week. And then it also encompasses all of our imaginary numbers. And so when we're talking about both of these possibilities, the imaginary numbers are the ones that result from any time that we have a square root of a negative number. So those are the ones that we have to pop out the eye and to be able to work with them. And so essentially what they have done, mathematicians have done to create this idea with complex numbers is to say, okay, every number I could possibly write, I have to find a way to be able to represent it with a real part and an imaginary part. So what they do is they say, well, if it's the real part, we'll just call that, we'll use the variable a to represent that, just to say here, this is just a straight up number. We can put any real number there and it's going to be fine. And then the imaginary part, they have to include an I. So they say, well, this could be anything that has some kind of multiplier here. Now that multiplier can be anything like a square root, it can be pi, it could be 7, it could be 5/3, it could be any of that. But what it essentially tells us is that every number in the complex number system can be written in the form a plus bi, where this part here is our real part, this part here is our imaginary part. Now, to give you an example of something like this, what I'd like to kind of show you is this. So like, let's just deal with a real number that we absolutely know. We are going to say the number, let's go with 7. Now, if I'm going to write that in a format that's going to be using the complex numbers, 7's pretty easy. Clearly, it's a real number, so that goes with our real part. That is going to be 7 plus. Now, I've got to be able to have the imaginary part for it to be in the complex numbers. The way that you would do it if you have a pure real number is you take that coefficient, that b, you just say, all right, we're going to make that a 0. Because 7 plus 0y, well, we know 0 times anything is 0. So it's kind of like saying, well, this part doesn't really exist. So it's 7 plus nothing. So it's just 7. But because I can write it in the format a plus bi, we can consider it to be a complex number. Just like if I've got an imaginary number, and for this one, we'll do kind of a quick review. Let's say I've got the square root of -6. Now, 6 doesn't break down, so we can just keep it like that. First thing that I would do with that negative that's on the inside of the root is I would pop out the I. It's going to be right on the outside there, I root 6. And since I can't simplify anything else, that portion right there is the way that my imaginary number would look based upon what we did from last week. So to write that in the format of a plus bi, well, right now we don't have a real number part. So this had a 7, but since I don't have a real number component to this, I'd make that as a 0 plus. Now, I could write I root 6 because that's kind of easier to look at. But if we're really writing it in the form a plus bi, my a is 0, my b is that root 6, and then there's the I for the imaginary part. So it would actually be 0 plus the square root of 6 I. Now, if you notice, I've left a lot of space here between the root 6 and the I. If you have to write it in this format, and we're normally just fine with you writing it this way, you want to make sure that there's space, because having an I underneath the square root means you're taking the root of a square root of -1. It's just kind of a lot to mess with. So just make sure if you're writing it in a plus bi, our real part is this one, our imaginary part is this one. And in the case of something like this, that's the way that we write both of them. But what you'll find is that since all numbers can be written in a complex number system, you're going to be dealing with a lot of different things. So since you're going to have a ton of numbers that are going to be in the a plus bi form, they could give you something like 3 plus 7i, or they could give you 6 minus 15i, or they could give you 27 plus 32i. I mean, we could write 100 of these and it would be fine. And they could also write them with radicals like I have here. But what we're going to be doing today with a lot of the work is we're going to be adding and subtracting these, which is really straight up easy. Now, we remember when we're talking about an I is just equal to the square root of -1. But since I can't do anything with it, I essentially just treat it like a variable. And when I add and subtract these things, what I'm going to be doing is combining like terms. So if I'm looking at this, let's say I take my first two. I go 3 plus 7i, and I add to that 6 minus 15i. Now, I'm just adding them. I'm not multiplying. So the parentheses are just there to kind of show you that you have two different numbers. So if I just drop those, 3 plus 7i plus 6 minus 15i, now I'm just combining like terms. I combine my real numbers together. I combine my imaginary numbers together. 3 plus 6 is going to give you 9. 7i minus 15i will give you negative 8i. If you notice, my final answer is also in the form of a plus bi, just that your a is 9 and your b is negative 8. Again, it's not difficult to do. Now, when we're doing this, most of the time they're going to be pretty straight up like that. And so like if I'm going to do a subtraction one, let's say I've got 14 minus 6i minus, let's go, negative 3 plus 8i. Okay, the only thing about these that you have to worry about is just look in front of the parentheses to see what you're doing, because we're still just combining them. You can either take them one at a time and do 14 minus negative 3 and negative 6i minus 8i, or if you wanted to, you can drop all the parentheses by distributing that negative to both things. So we would have 14 minus 6i minus a negative becomes a positive 3 minus 8i will be minus 8i. And again, you're just combining like terms. 14 and positive 3 will give you 17. Negative 6i and negative 8i will give you negative 14i. Still pretty straightforward. You're basically just combining like terms. The only other thing that you might be given that would cause a little bit of confusion is if you have something that's given to you in a format that hasn't been simplified. So I have like, let's say 5 plus the square root of negative 16 plus 8 minus the square root of negative 25. Okay, now both of those are written in such a way that we don't have them in the imaginary format, but they're not too hard to deal with. All you really want to do is just simplify those radicals first. Anytime you've got a negative under the root, again, you pop out the I root 16. This one right here is going to be I root 25. And then when we see that, we can just simplify these radicals. Root 16 is equal to 4. So this now becomes 5 plus 4i plus, I got my 8, the I root 25. Well, root 25 is just a 5. So this is going to become minus 5i. And at this point, now it's just like what we did before. Since it's addition, we just drop the parentheses. 5 plus 4i plus 8 minus 5i, and I combine like terms. 5 plus 8 is going to give you 13. 4i minus 5i is going to give you negative 1i, or just negative I. Again, all in the format of the a plus bi, where your a is 13 and your b is negative 1. So that should be everything that you need to be able to understand what complex numbers are and how to add or subtract complex numbers. So with that being said, I will say to you, thank you and have a wonderful day.